So we're going to write some equations. On number 3, I'm not really going to graph, but there's a graph there if you want to plot the points and analyze. The reason why I'm not going to graph on number 3 is because they gave us the center. And I can also tell based on all of these ordered pairs if it's horizontal or vertical. I know for sure this is a vertical ellipse because all of the y coordinates are changing. So if I know it's a vertical ellipse, it's a hyperbola, guys. I am so sorry I said the wrong word. It is a hyperbola. It needs to have a minus right there. It still equals 1. I know that it's vertical, so I know the y value comes first. I even know the center. I know what to put in those parentheses. The center of the hyperbola is -5, +4. So y minus 4 in those parentheses, x plus 5 in the other set of parentheses. All right, time to focus on the denominators. Remember, this denominator is a squared, and a is the distance from the center to a vertex. So if my center is right here at -5, 4, and my vertex is here at -5, 6, that's 2 places above the center. So I know my a value is 2. But remember, everything's squared in the equation, so we need to write a 4 here. All right, we need the other denominator, which is b squared. We have a focus. Remember, a focus is a c value from the center. And remember, the c value was at 4. This is way up here at a 9. So a +4 to a 9, the c value is 5. That didn't really give me the b value. However, if y'all remember, c squared equals a squared plus b squared for hyperbolas. So we're going to have to use our other tools here to get the final piece for the equation. Regular c was 5, so c squared is 25. We already have a squared. We just wrote it right there. And when we subtract 4 from both sides, that's going to be the final piece for the equation. So we know that 21 is that other denominator, and that's it. So don't forget, guys, sometimes you're going to have to use this more than just graphing. So if you get stuck on something, writing an equation, go back and think about your a squared plus b squared. If it's a hyperbola, remember, if it's an ellipse, that's a minus sign right there. Okay, let's take a look at the next one. So for the next one, it might be useful to kind of graph these points because all I have are 2 foci and a vertex. I don't even have a center here. But again, if I analyze what's moving here, I can totally tell the direction. The -3 on all of those x coordinates is remaining static. So this is going to be another vertical hyperbola. And again, I mean, I can go ahead and set this up a lot. I could put a lot of stuff here. All right, so if you guys remember, foci are c distances from the center. But I have foci, just these ordered pairs. And if you notice, a +4 all the way down to a -8, that is a movement of 12 units. It was way up here, then it went way down here. So that's 2c. Which means plane C is 6. And if plane C is 6, and remember C is the distance from a focus to a vertex, then if I plot this, I can go ahead and plot this at -3, +4. 1, 2, 3. 1, 2, 3, 4. 6 places below that, that's where the center is. So the center is going to be down here at -3, -2. Now we can fill in the top. So if the center is -3, -2, then this is going to be x plus 3 right here, y plus 2 right there. All right, time for an a value. We can figure out the a value because we have a vertex. So remember, the vertex is -3, +2. So what's the A value for this?
16.
Oh yeah, she already squared it. Good job. 16 goes right here. It sure does. Good job. All right, we're going to have to do the same exact thing to find the B value. So remember, our C value was 6, so let's square that. We're going to write that 16. And guys, just subtract 16 from 36, and that's going to be the final piece. So B squared for this one is just 20.